everyone, we're going to use the principle of mathematical induction to prove that 1 plus x raised to the nth power is greater than or equal to 1 plus nx, and x is greater than -1. We also want to say that when you're using mathematical induction, your n is a positive integer, so it belongs to the positive integers. All right, so we'll get started. First thing we want to do is show that it's true, our statement is true for n equal 1. So you plug in 1 to both sides here, you get 1 plus x to the first power is greater than or equal to 1 plus 1 times x is just x. So since these are equal, and we have this equal sign here, it's true. You could check with different x's and stuff, but we want our x to be positive, and we'll continue on. Now we're going to do assume. What we're doing is we're going to assume that it's true for some n equal k. So if n equals k, then we're going to prove that it works for n equals k plus 1. All right, so let's get started. Let's change this to k. So we have, or this part, let's do that one. So 1 plus x to the k is greater than or equal to 1 plus kx. So that's our if statement. If the assumption, then the proof. All right. So now if we do that, we're going to prove that it works for our next term. For example, n equals 2, n equals 3. So we're going to take our k's and insert k plus 1's. So we're going to do 1 plus x to the k plus 1 is greater than or equal to 1 plus k plus 1 to the x. So therefore, I can rewrite this k plus 1 as 1 plus x times 1 plus x to the k. Because remember, your powers of exponents, or your properties of exponents, use your product rule. Since these are the same basis, this is the expansion form of this, because you would just do 1 plus k, or k plus 1. So we know that this is going to be greater than or equal to this part here, we already know is greater than or equal to 1 plus kx. This part. And this part, we can just put in front here, because we're trying to get it to look like this. All right, so if this is greater than this quantity, then this quantity are the same, so it's still going to be true. All right, so let's FOIL this out. We get this equals, right here is going to be 1 plus kx plus x plus kx squared. Now I can rewrite that as, so I'll write it again, 1 plus kx plus x plus kx squared. And I can rewrite this as 1 plus, and factor out the x, and then put k plus 1 plus kx squared. Now this is going to be greater than or equal to 1 plus k plus 1x, which is what we wanted to prove. All right, because you've got this x squared, and you have this x here. So this is your extra part here that you have, the kx squared. And that's because k is positive. Your x squared is also positive, and 1 plus x is positive. So given all that, this is true. So we did our proof. And that's it. Thank you. Have a nice day. Bye-bye.